I want to talk today about the grid generation tool, GMSH. So this discussion is regarding how we download, install, and just look at the general interface of GMSH. I have to go to this website, which I'm highlighting here, gmsh.info, and this page should come up. And let's just go down the page so we understand what we're seeing. GMSH is a three-dimensional finite element mesh generator with built-in pre- and post-processing facilities. And here are the authors. And it's really all one encompassing web page. But let's read their own description of their software. It says GMSH is an open source 3D finite element mesh generator with built-in CAD engine and post-processor. It is a design goal to provide a fast, light, and user-friendly meshing tool with parametric input and advanced visualization capabilities. GMSH is built around four modules: the geometry, mesh, and solver, and post-processing. The specification of any input to these modules is performed either interactively using a graphical user interface in ASCII text files using GMSH's own scripting language, or using C++, C, Python, Julia application programming interface. What this basically means is it's GUI which runs a scripting language. And in this series of videos, we're going to look at the scripts that are generated by the GUIs, but sometimes it'll be beneficial to model them or modify them, and also look at the output files. So we're using this as our grid generation tool for CFD. So when I'm talking about GMSH on related grid generation tools related to the class, we will basically look at this as a pre-processing tool where we can have a CAD engine, we can have a CAD cleanup, like is shown in these figures on the right, and then creating three-dimensional or two-dimensional geometries on the surfaces and volumes. So this is what we'll look at. So once you go to this website, you just need to scroll down here to download. And in download, you'll see the current stable releases. And as of this video, this is 4.60 on the 22nd of June in 2020. So here are the basic binaries. If you're on a modern Windows system, I recommend getting Windows 64-bit, and you'll see if I highlight that, it's essentially an executable installation. So just like you install any other type of code or program, that's just what you need to hit and download that. If you're on Linux, you can get a 64 or 32-bit Linux binary, and I'm on Mac OS X, so I would download the Mac OS binary. Right now I'm on Catalina. See, if I highlight this, if you see down this part of my screen right here, you'll see Mac OS. It's a .dmg file, so that's a nice file that I can use just to install the program. So it's a graphic user interface installation, and I just recommend installing it to your CFD directory / or / GMSH, a subdirectory called GMSH, and that way you'll have it right there. And you can create all your mesh files in each particular subfolder, just like we created subfolders for the CFD files. And we'll show that in a second. Anyway, let's just scroll down just to complete the website. On the right, they have different images of example meshes you can create. You can do all this with GMSH. We're only going to be creating meshes. We're not going to be using visualization. We'll use ParaView for visualization. And the documentation is very important. They have some of their own general presentations. These are basically PowerPoint PDF presentations, so you're welcome to read through those. They're very interesting. So there's a general overview. So let's just open that in another tab and look at it in a second. We have a reference manual. You're welcome to look at this, but I think I'll just try and teach you all the basics, and it's easy to grow from there, and that way these manuals will make sense. They have a number of screencasts. These do not necessarily have sound, but they're just like this video. They made their own screencasts, and you might gather some information from them. I think my descriptions of how we're doing grids for CFD will be a little bit more helpful. They also have their own wiki and all these other things, changelog for the codes, and you can also get, of course, the source code right here under downloads. So you can actually see the source code that is used to compile this program, so you can see all the grid generation technology and algorithms, and I think that's pretty interesting personally. So if you want to look at that, great, you can use it for your own education. There's licensing issues, but basically this is free to use and distribute for everybody. Don't worry about that too much unless you're interested in the legal framework of this code, but it's completely free and open source. And there's a number of links, and it does use two types of CAD engines, and you get to select these when you start the code. One is called Open Cascade, and of course the other one's like their internal one. Generally we'll be using Open Cascade when we get the select, but just know it's there and you have your own choices. And they have their own references here, and it's awfully nice to reference their software, so if you write a publication, then you can reference it right here. So go ahead and download the code from the download link for your particular binary, install it on your computer. You might also check out their manual right here, and you can just scroll down. You can see who they are, their background, and their philosophy. And I think this is worth a scroll through too, just to read about their history and what they've done here in their philosophy. You can see that they've really focused on implementing the very best grid generation approaches, but in a most elegant manner. And it's a very simple code, and they focus on elegance and maybe simplicity over something that's more complicated. And that's probably part of the reason it's successful in what it does. Anyway, take a look at yourself when you get a chance. On your Windows, Mac, or Linux system, and now let's just look at the file structure of how it's installed before we run it. So generally, I keep a directory called CFD, and in my CFD directory, I have a number of subdirectories. I have a direct numerical simulation directory. That's for a different program. I have the GMSH installation directory. I have the installers for SU2, ParaView, GMSH, and all the other CFD codes I have. I have a collection of manuals, software, and in my SU2 directory, that's where I'm having all my CFD codes and runs. I've also made another subdirectory called grids. So let's just go into grids. I type in cd grids and ls for list. Let's do lsah for human readable, and there they are. So for in this particular class, I've made a number of grid files. For example, I made a simple triangle. I have the most smallest case possible. I've made a cylinder grid. For every grid I create with my grid generation codes, I make its own subdirectory in grids. And you'll see this is a very wise thing to do, to separate your files and save often under different file names in each particular directory. For example, if I go into class homework 1 and list, you'll see I have a number of files. We'll look at these files and what they mean later. You'll see one file is tiny.su2, so that's the SU2 grid and boundary condition file. These other files are generated from GMSH, and we'll look at those in a bit as we create our first case in a later session. But first, let's look at the installation. So if we cd down and cd down again, and we go into GMSH, cd GMSH from the CFD directory, I'll type in clear to clear the screen and just do an lsh command to see what's in it. So this is almost a native installation. I've done a few things in here. I've also downloaded the official GMSH tutorials, and I extracted those in the GMSH directory to just keep them there. So you can also go to the GMS website and download the tutorial files. Anyway, in there you'll see there's an executable. So on Mac OS X is gmsh.app. And of course, I could type that in to run it, or I could go into my File Explorer and double click it. In Windows, of course, you'll also have your executable, which is probably installed in like a folder under the Start menu. Or you can go into your installation directory, of course, and execute the code. So go ahead and execute GMSH, and we'll see what comes up. You executed it, and this is what comes up. The first thing you'll see is this basic window, and you'll have pull-down menus if you're Mac OS X or Windows and Linux. You'll have a little control bar at the bottom too, and you'll have a middle pane. This middle main pane is where you see your models and visualizations. You can see you have an XYZ coordinate system here in the lower right, and you have a left pane, just like ParaView, you have like a pipeline menu, and under these modules you have three main modules: geometry, mesh, and solver. We're mainly going to be operating in geometry to set up the geometry in CAD, etc. And then we'll also looking at the mesh, which of course creates the computational domains. And this is an unstructured grid generation code. Well, remember, we'll be talking about this software in terms of using it for CFD. Now let's just go through the basic interface so it can be understood. Up here we have the pull down menu, so if I hit GMSH, you can see I can basically, the only one that's useful is quit and about GMSH. So I can hit About GMSH, and it says all the information, including my version. That's exciting. Then we have File. Anytime you start GMSH, you'll probably want to make a new .go file. So you can see one annoying thing about GMSH is it automatically creates an untitled.go file in my home directory. So after you run, you can probably go in and delete the untitled.go file, or else you get these untitled files in your home directories. That's really annoying, and I think that should be changed. They should probably write this initial file into the home directory that you're choosing and not create one for you. So I would go to File, New to create a new one, but we'll do that in a bit. Right now I just want to cover the interface. Open will open .go files and meshes. Merge, the file merge command will actually open a CAD file. It'll open a CAD file. So you will see a window coming up where we can, of course, select a CAD file and merge it in. All we have to do is click it and open it, and you'll see here there's a whole list of files. This goes down off the screen that's being recorded, but many different files that can be opened, including STL files, IGES files, step files, so STL. These can all be generated also with. Okay, let's continue. You can also clear, so clear will clear this current GMesh run, but I really do recommend just exiting a GMesh and restarting it. You can also delete, of course, this and rename the particular file. Down here are very important things. You can save meshes, the modeling options that GMesh is running, and you can also save the particular options that you select as default. So in the options menu, you can, if you get tired of resetting them, you can save them as default here. This is one of the most important buttons. So after you set up your grid and boundary conditions in GMesh, you can click Export, and a window will come up and it'll ask you how and what CFD solver you want to export your grid to. So we'll do that later in the class too. Under Tools, we have a number of things. The first and most important, of course, is Options. So this is the Option menu. They have basically tabs here on the top, and on the left you have different, different pipelines for different options. So these are general options. Like if I want a dark interface, you can see I click and it becomes dark. That's great. One thing you'll notice right away is there's no like confirm or save option here. Anything you do in here is done when you enable it. So here's like a graphic user interface option for anti-aliasing. So generally these are all about the colors and execution of the code, and you're welcome to play with these as much as you want. If you get in trouble, go under Advanced and hit Restore Options to Default. The next one is geometry. So this is important. You might have a geometry tolerance. This is just your tolerance for, of course, creating your geometries. There's different geometry options. So a lot of these just leave as they are. They're not going to be too important. If you get tired of the colors, you can go in here and change the colors. Next is the mesh. This one's very important. And in class, we talked about different algorithms to create computational domains. So for example, when we're creating surfaces, or the surfaces of 3D volumes or 2D grids, we could select, say, frontal Delaunay methods. We can let GMesh automatically create or select a grid generation code. And they also have some other ones which are more experimental. So in the grid generation world, there's a lot of people working to create better grids and algorithms. So these are some of their implementations of these more popular methods, and they're experimental because of their own implementation. In 3D, this is the algorithm that's being used in 3D. They have a few choices: Delaunay, a frontal advancing method, and what they call XTT and MMG3D. So once you set up a grid, you can actually go into this options menu and select different ones and get completely different grids. Down here is a number of iterations to smooth the mesh after it's been created to try and create better grid quality statistics. Now, this elemental size factor is one of the most important options. This will scale the sizes of all elements as a single value. So right now it's a value of 1 unit. The units could be meters or feet or whatever factor you want. There's no units implicitly in a mesh generation code. It'll just put out values, and it'll be up to you to decide later what the units are. Min and max element sizes are the smallest element that could be created and the largest. So right now it's over an entire range from 0 meters, which doesn't make much sense, but there's no bound, to 1 × 10⁻², say, units, length units. There's other options in here, and you're welcome to go through them and try different things. Some of these, like visibility, will display the meshes on the screen once we create a mesh. And color, of course, changes the colors of the mesh. So we will go into visibility once in a while, but these can be accessed quickly from the menus down here, which I'll explain. Do not worry about solver. GMesh can actually hook in finite element solvers, and we won't be doing this. And the same with postprop. So the main options you'll want to look at to make your life easier might be in general, geometry, and mesh, at least from a CFD user point of view. So let's close this menu by hitting the X and go back into tools. So there's plugins. We're not going to use any particular plugins. Visibility will just bring up once we create elements or entities in GMSH, we can actually enable and disable them so we can view different parts. That's much like CAD software, same terminology. Clipping, we're going to use in the later class to try and examine internal meshes in 3D. So we can use the clipping menu, and it's basically 4 coefficients that correspond to a plane. And we can actually clip the geometry or the mesh by selecting 1 or 2 of these and then selecting coefficients, and it'll make a plane in space. It'll basically cut off half the domain across the plane. So we'll try that in a later class too. Just showing you the interface right now. Once we create a mesh, there'll be this button called Statistics. We can open up Statistics, and we just hit the Update button, and we can see the statistics of our geometry, our mesh, and don't worry about post-processing. We're not doing post-processing on GMSH. So once we create a geometry, it might have a number of points, curves, surfaces, volumes, and physical groups. And once we create a mesh, then we can here open this up with our mesh created and hit Update, and we'll be able to see the number of nodes, points, lines, triangles, etc., which we've talked about in class. And we'll also be able to look at additional statistics of the mesh for its quality. Under Window, this is just controlling the windows in your particular operating system. So this is for Apple OS X, and we might be able to split our windows and stuff to get different views. So this is pretty straightforward, and honestly, I almost never use these things, but you can split the windows to get 2 different views when you're operating, just like in a CAD software. Finally, under Help, you can already click here if you want. That'll just bring you to the online documentation of the GMSH website, but I've already showed that earlier in the video. So you really might also look at keyboard and mouse usage. If you bring this up, here's all the shortcut keys. So GMSH doesn't typically remind you of shortcut keys. Let's just go from the top to the bottom. You can scroll down here and see how many there are. And I'm just going to note a few. They put the most important ones at the top. Now basically when you move the mouse around, you're going to be able to highlight things, and you'll see this, I'll talk about as I do it, as I create a few grids and a few structures. You can use the middle mouse button. Left mouse button is going to change the view. Controlling the middle button is going to bring up an orthogonal display. A right button will pan the display. So we can try that all in the view. Up top, there's going to be 2 keys that are most important. One is going to be E. And anytime you have something selected with options shown, you hit E to perhaps apply something or create geometry. E is the most important key, and it'll remind you what E is on the screen, and Q will be quit to get out of a particular option. So E and Q are the 2 most important keys you can press in GMSH, and when I was learning I didn't really realize that, but you'll see what I mean. Everything else isn't as important, but you can always go to Help, Key and Mouse Usage to see all the keyboard commands. They have really kind of shown this in one place to try and keep some sort of elegance in the code and GUI. Let's look at the rest of the interface now. As I said before, this is the main window where models appear. So if I left click and drag, you can see in the lower right corner, I'm changing my viewport. And if I right click and drag, now I'm panning. So we'll try these with models later. I have an external mouse with a wheel, so if I use the mouse wheel, I'm actually zooming in and out. Now let's look over on the left. Under modules, we care most about geometry and mesh and not so much about solver. So if you click these little triangles, it'll expand geometry. Let's look at geometry. And that's where you spend a lot of your time, is taking a CAD model and cleaning it up with geometry or creating simple geometry entities. So let's look at perhaps some of these. Now, under elementary entities is where we perhaps can set the geometry kernel, and we could just left click. We always left click in here like Open Cascade, and now it says near the bottom setting Open Cascade factory settings. That's using the external open source CAD engine. If you want to add geometry, we open up Add, and you'll see we can add points, lines, splines, Beziers, B-splines, circles, arcs, ellipses, rectangulars, discs, plane surfaces, surface fillings, spheres, cylinders, boxes. And so we can add all these types of basic shapes in here to do almost all the type of CFD we're interested in for basic flows in this class. If something's more complicated, we can just do all these operations in a full-scale CAD engine like, say, SolidWorks, and import it with the file merge command, which is right here where my mouse is. Anyway, I'll show these later when we just do some basic cases. Under transform, we can translate, rotate, scale, and apply symmetry. That is like mirror some geometry about applying a symmetry, just like we do with a symmetric boundary condition in CFD. So, well, these are pretty straightforward. If you click a button, if you click an entity and click translate, you can translate it. Extrude is another simple one. We can translate, rotate, and create a pipe. So if we say have a plane, we can extrude it or rotate it with translation or rotation to make like a cylinder or a box with these two commands respectively. Easy. Boolean is interesting. So we can take two shapes and find their intersections and create a new shape. We can do a union. So if we have like shape 1 and shape 2, we can fuse them and make a single shape. Or we can take a difference. So if we say want to cut a hole through a box, we would take the difference between the box and a cylinder, which represents the hole. So you really need to have a CAD class and understanding CAD to really understand these types of operations for elementary entities. We can also apply fillets and split curves with these two operations here. Here's the delete button. So if we hit delete, we can then select an entity and then push E to get rid of it. So let's just scale these down. So this whole menu under geometry is for, of course, creating entities. The next important one, once we've created those physical domains, not the grid, but the physical domain of this fluid, we then can open up physical groups. And then we might add some. And so the different physical groups are very simple. We might, in our class at least, have curves and surfaces and volumes. We can also remove these groups by using similar operations for points, curves, surfaces, and volumes. So for example, if I have a box and I want to add a physical group, like say a surface on it, I would left click surface and I would have a name and I would just type, say, inlet. Inlet. And then I could apply the inlet physical group onto a surface of, say, my box. That surface, 1 of 6 on, say, a cube, would represent the inlet boundary condition. Now, these names are also shown in the name list of, say, the CFD solver. So when the CFD solver reads this grid file and boundary condition file, it could see the word inlet, and you would tell the CFD solver that inlet means an inlet boundary condition. So we'll apply some boundary conditions later to show you how this is done. I'm just showing the overall interface and big picture. So let's close up add. So that's physical groups, is how you're adding in boundary conditions and adding in a fluid domain. So one other thing you have to do is, when you're done, is tell GMesh where the fluid resides in your domain. So you would just click volume and maybe type in fluid. I would then click the volume itself and push E to apply. If I don't want to do this, I would push Q. So here I'm going to push Q. Oop, I have to select the window. Done. Okay, let's look at the last part. Let's close up geometry and open up mesh. If we have set up the mesh options correctly, I can now, or geometry correctly with physical boundary conditions, I can then open up mesh. And here you'll see a lot of options. The most important ones you'll have are 1D, 2D, and 3D. So if I have lines and I push 1D, it'll discretize the lines in the domain. If I hit 2D, it will try and automatically create two-dimensional surfaces and domains. If I hit 3D, it'll try and create volume meshes from the two-dimensional meshes. So I can create my whole three-dimensional grid in one click by just clicking 3D. It'll automatically go through 1D, 2D, 3D. Now, if you're redoing the grids, I recommend going back and hitting 1D first, then 2D, then 3D. This is just from my own experience. There's other tools in here which we won't be using much. High order tools will try and create high order grids. Don't worry about that. Once you've created a grid, you can click Refine by Splitting, one click. So if you have a 2D or 3D grid, you just left click Refine by Splitting, and it'll basically double the number of grid points in every major direction. It will refine by splitting every element in the mesh. You can also click Smooth 2D, and it'll try and smooth the two-dimensional parts of the domain. You can also go down here and delete, and you can delete individual elements, curves, surfaces, or volumes of the mesh. So this delete operation operates on the discretized domain. It does not operate on the geometry. So that's why in geometry there's a whole separate delete command, which deletes geometry like points, lines, surfaces, curves, and volumes. Nonetheless, the next important option you'll see is under define. So we go under Define and open it. And here we can click Size at Points. This will change the mesh resolution at a particular point. Another important option, which I'll show in this class, is Size Fields. By clicking Size Fields, I can try and scale certain parts of the mesh. Now, there's two other options which we'll be looking at in this class, Embedded and Transfinite. We'll mainly look at transfinite. We'll look at curved surfaces and volumes. The transfinite meshes will let us create an unstructured mesh with structured characteristics. This is going to be critical when we're trying to resolve the boundary conditions. And we'll look at a lot at that in a later class when we're looking at the structured mesh generation. So that's basically the overall drop-down menus which we care about. You can look in Solver too, but you actually have to link a solver in with GMesh for it to be useful. And we have our own solvers for CFD, so we're not going to link them with GMesh. And we're going to use the pair view system for visualization. Okay, let's keep going. The other part of the interface that you really care about is down here. So there's a little button here. You can left-click that. And there's a drop-down menu, and it has a number of buttons you can click. Unfortunately, it dropped down below my recording of the screen. But here, there's just options, which are just quick options, which you can see in the Tools Options part of the code. Down here is an important button. This just can change models, so you can have different models open. Don't get confused here. I just really recommend only having one and open at a time. But using this, you can go to different models back and forth. You have to open each model individually, and more will appear here. And then these little buttons here will open up a quick access menu. And you see by clicking that, all kinds of neat little options appear. And I'll talk about those in a second. But you can actually double click your screen anywhere and the same menu comes up. So you don't have to bring your mouse down here and hit the O key. No, just double click out here and then keep your mouse button down. And if you can't see your model, you can just click Reset Viewpoint. You can reselect the rotation center, so when you drag your mouse, you can rotate about another point. You can split your window in horizontal, vertical options, so to see different windows and parts of your model. You can turn on and off axis. You can change your projection model from orthographic to perspective. That just changes the way it's plotted on the screen. You can open up the options menu here. So if I was too lazy to go to Tools Options, I could just double click, hold, and hit General Options. Very simple. Double click again, I can see and change the visibility. If I want to hide points or curves or surfaces and only see volumes, I could just keep double clicking, unselect them. So I double click, points, release on curves, double click, release on surfaces, easy. I can also open my geometry options, but that's just part, of course, the main menu, just a quick shortcut. I can turn on and off mesh visibility. So if I create a mesh and I don't want to see it, I just want to see the original structure, I can actually turn on and off the 2D elements or 3D elements or nodes of the computational domain. I can also turn on and off the mesh visibility with one button. And you'll see every time I do this, it's changing the option in the lower part of the menu. Cool. Double click again. I can also change the most important factor for an unstructured mesh, for a general mesh, the global mesh size factor. And it lets me say, put in 1 as the default value, but let's just change it to 0.5. I hit OK. Now let's go back in the mesh options, all general options, and I go to mesh and general. And you see now the LML size factor has changed from 1 to 0.5. Let's close that and let's finish. Finally, you can just drag down to all mesh options and come up to the mesh options again. So you see there's lots of ways to do the same thing, and you can become really quick and efficient. So remember, the two most important keys are E for apply and Q for quit the menu. And these little drop-down menus where you can left-click anywhere are your friends. And remember, when you left-click one of these, it is doing something. It's not waiting for you to confirm. There's really no confirmation dialogues other than the E key in all of GMesh. So I recommend, as you do an operation or a major operation, like creating a grid or surface grid, I would do file. I would go and copy your mesh file in its directory to a backup file. And I would rename each backup file as I do major operations. That way, if I make a mistake, I can backtrack. You'll see in a lot of mesh generation softwares, and GMesh included, there's not very much often an undo option. So I don't see that in here. There's not like edit undo. And that's because the amount of memory a mesh generation solver uses is tremendous. And so it can't save previous meshes and mesh operations. And so if you mess up, it's easier to load a previous mesh than it is to redo everything. And so get in that habit right away. Now, the first thing I do, of course, after showing you all these options today, is save file new. This window comes up, and I would maybe want to make a new folder in my directory, and I'll call that folder just test for fun. And now test comes up, and I'll put test in the file menu. And it's asking me, oh, do I want to say test with a .go extension? Of course I do. So I'll say .go. And it says, which geometry kernel do I want to use? So I'll use Open Cascade. There's advantages and disadvantages. Open Cascade is the open CAD framework, essentially, for the geometry operations. And built-in is the built-in source code of GMesh. So I'm just going to use Open Cascade for now. And now down here it says done reading users SAE Miller Google Drive CFD grids test.go. And so now I've created my first GMesh file called test.go, which is essentially a script file. It's a text file. And when you reload GMesh, it's going to reload this script file and rerun it. And then if there's an associated mesh, it'll read that too as a separate file. That is, I could say save mesh, and of course, open that mesh later. All right, thank you very much for your time today. That's the general installation and overview of GMesh. Next time, we're going to try out some simple GMesh operations to get you on track to grid generation for CFD using the simple GMesh system.